the welcome everybody to the second conversation with Zoran and I about lab analysis and bottling QC. I sent out a quick little survey yesterday and asked a few questions just for us to get an understanding of who people are and what kind of bottling they're doing. So the top line here has the 5 questions. Where do you do your bottling? And I asked, does the winery have its own bottling line, or do you have a mobile bottler that comes to your winery? And the third option was that you send your wine to a custom bottling location. So all 3 options were available, and we got more people said they bottled on their own bottling line than I expected, but there were a good number of people that used the other options too. And then you can see in question number 2, we had
just a second,
yeah.
Julie. I would be curious to hear that or see it. They have their own bottling. Does it mean this is automated bottling, or it's actually just by hand?
I did not ask that question.
Yeah, because I was actually surprised when I saw how many people they have their own bottling line, and I was wondering whether it's like automated monoblock or it's actually just the spouts, with the 6 axis. Just
right. Well, I would say anyone that's joined us on this call, you are welcome to unmute yourself and join in the conversation at any time that you would like. I'm happy to have this be a roundtable conversation. So if you answered this survey and you want to talk about your answers, you are welcome to do so.
Julie, this is Bob. Just manual line, as you know.
Yeah. So you're doing it by hand as far as filling your bottles, Bob?
Yes.
Yeah.
Vacuum.
Oh, okay. And anybody else that answered?
This is Meredith. We send our wine to another winery, but they have an automated monoblock bottler. So.
Gotcha. So I think that kind of is a good scope there, from doing it by hand to sending it to somebody else that has a big production facility. We have kind of a wide variety of bottling going on.
This would definitely be critical depending what the volume is that you are producing at a time.
Right.
If it's a relatively small volume, there is nothing wrong of doing it manually. But in that case, I would probably suggest that you buy maybe the filler bowls that they can be gasable, like with inert gas, or you actually have to create maybe fast connecting fitting and do gassing on your own of the headspace in that small filler bowl as you are bottling. Also, right. You could pre-gas your bottles too with inert gas.
Mm-hmm. And then my second question was, how many times a year do you bottle? And we had a range from twice a year to, there's one winery that said 10 times per year. You have kind of a nice mix of that as well.
Does this mean number of days or times?
No, this is actually number of times within the year. So that would be, once in the spring and once in the fall versus almost every month bottling. Just so there's kind of a mix here. My third question was, what information or standards do you give the bottler? And a lot of people did not answer this, but we got a couple people that said, here's one answer. Besides the standard bottle mold and capsule type, label type, size information, I tell them what size inline filter I want. So that's the question about 1.2 micron, 0.65 micron, or 0.45 micron filter. Another person said bottle and label dimensions, filtration needs, volume and case count. And then another person said, we monitor fill volumes, O2, CO2, closure QC. So they went into a lot more detail about what they are telling the bottling line and what communication they're getting back.
And clearly, these are the people that more often they do bottling. And
Yes.
that's what happens. The more often you do bottling, the more often you find out there are things that they haven't been covered. And then you just kind of keep on developing it.
Yes, and he kind of explained as well that they have a long-term relationship, so they've gotten comfortable with communicating more. So they also said if there are changes to the mobile bottling line, they have conversations about how things have changed and what other things that you need to look for. Okay, the next question was, what information does your bottler give to you? And one person said it had more to do with start time and when they're arriving, that kind of thing. Time expectations, electrical requirements, water, labor, etc. And then you can see this long answer. We discuss line changes and the order that the wines are going to be bottled in, and that sort of thing. And let's see, the last question, anybody have any other comments? And one person said, we do small lots often. And another one said, we have the convenience of bottling our own wines ourselves, so we have control over a lot of the QC ourselves.
That's good. It's interesting actually to know, the variety of you, so we can actually cover that as we are discussing and presenting. And also, if you ever have a questions, please step in and ask questions. All right, so maybe I can now start with the presentation that I have to share.
Yeah. Okay.
What are we seeing? I did something wrong. Sorry.
Oh, I'm seeing lots of pages.
Yeah,
I see my name a lot.
That's not what I wanted actually.
Okay.
To share.
Oh, there you
go. No. This, I'm sorry. There you go. You see that?
Yes.
All right. So this is just in general the winemaking production, and you see there is so much effort put into making a bottle of wine, and we put so much effort in all aspects of these, and quite often we kind of lose focus when it comes to bottling, and it becomes a nuisance, something that we have to make it. But the more you understand how important that part is, you definitely want to put the right effort to make it right, because you can ruin your wine there. Something about oxygenation, just to kind of have a perspective. When we are during harvest and crushing, definitely there is more macro oxygenation going, unless we are making a green winemaking, like people maybe in New Zealand would make a Sauvignon Blanc. But definitely at that point, oxygen is desirable. Yeast needs for growth. For alcoholic fermentation is reductive process. So there is a lot of oxygen going on, and most of the time is not detrimental for wine. It's fine. Then we go in a second part, post alcoholic fermentation, when that level of oxygen definitely is less needed, and it's kind of micro-oxygenation that happens to these processes there. They've been circled there. And that also includes bottling. And then non-oxygenation, this is just kind of the scale of oxygen that is kind of desirable in the wine at different stages. So during maturation in the bottling, there is also importance of oxygen actually getting into the bottle, but at very, very fine levels. Now, it's not the same thing bringing the oxygen through ingress through the closure and getting the huge gulp of oxygen just during the process of bottling. That's what we try to avoid. I know that some people that they're bottling screw caps, they're thinking, well, if my screw cap doesn't breathe much, I don't know why I need to mitigate the headspace oxygen under my screw cap. It is really important, because screw cap throughout the years is not going to bring you maybe 1-2 milligrams per liter of oxygen at the same time. if you're not inerting the gas in the ullage, in the headspace, under the screw cap, you will bring a huge amount of oxygen. As we speak, we are bottling here with the old bottling line that unfortunately has been modified by somebody in a very bad manner, that is very hard to maintain oxygen level, dissolved oxygen level in the wine under 1. Actually, the whole day we've been producing today somewhere between 1.25 milligrams per liter and 1.5 milligrams per liter. Screw capping it. Now, why is different under screw cap is important at gas? Because initially when people start switching to the screw caps, they were just using spirit bottles. And because spirit is much higher alcohol, you have to have a much larger ullage for the expansion of that high alcohol product. Wine is much lower alcohol product, so it's not 40%, it's 15%. It needs much less of a headspace. So the first thing that I was fighting actually when I was working with Constellation, when we were switching to screw caps, that we need to find the bottles with a smaller ullage. And I tried to prove that. Why is that important? Because Australians and New Zealanders started that much earlier, in the early 2000s, and their headspace is between 30 and 35 millimeters of a headspace, while we were using 56 to 65 millimeters. Just to put that in perspective, if you are using stoppers, cork stoppers or other types of stoppers, your ullage can be anywhere between like 13 and 15, 16 millimeters, which is way less than under the screw cap. That's why mitigation with inert gassing under the closure is critical.
Hey, Zoran.
Yes.
Somebody asked, what is an acceptable DO pickup on the bottling line?
That will really depend about your setup, because I can say what the desirable one is versus like what is actually happening. So for example, at this facility right now where I am, they're happy if they can keep it even under 1.5. In reality, ideal goal, especially with the new equipment, is definitely under 1 milligram per liter. Delta oxygen pickup between bottling tank and the bottle below 0.3. And quite often with new bottling lines, it's so easy to get even below 0.1. Now, all these measurements should be done with the modern DO meters. They're not polarographic. You should be getting optical readers. Definitely are much more responsive, but you still, it takes time. You have to be patient to get the reading. So I would say that it takes about 2 minutes, between 2 and 3 minutes to get a stable reading of the dissolved oxygen. Now, also to understand, each milligram of oxygen that ends up in a bottle binds about 4 milligrams of free SO2. So when you maybe measure, measure SO2 in your wine 2 months later, post-bottling, you will notice significant drop in free SO2. That drop is going to be due to the dissolved oxygen. Actually, it's going to be due to the oxygen present in the bottle, which is total package oxygen, and it's measured dissolved oxygen that is in the liquid, in the wine, and the headspace oxygen, which normally is measured in percentages because it's in gaseous form. If you're curious to find out what's your total package oxygen in your bottle, you can actually shake your bottle for 3 minutes minimum, up and down for 3 minutes. And you take 2 bottles off the line. 1 bottle you don't shake, the other bottle you shake for 3 minutes. Measure the DO in unshaken bottle, and let's say it's 0.6 milligrams per liter. You shake the bottle, it's going to be higher than 0.6 because you will be pushing a gaseous form of oxygen that is in the air, in the ullage, in the headspace. And depending how much of that is in there, how much has been evacuated by vacuum force during corking, or actually pushed with the liquid nitrogen drop during the screw cap processing. That level in a normal situation, normal run, I expect it can be even under 1. But if it's 0.6 to start with, probably it's going to be somewhere between 1 and 1.2. And anything that is below 2 milligrams per liter, that's pretty good result. Currently, I can tell you on the bottling line that I'm running right now, we were having DOs, so that dissolved oxygen between 1.2, 1.5, and a shaken bottle with about 45 millimeters of ullage under the screw cap that hasn't been, that hasn't run inert gassing under the screw cap. The pickup was additional 2.5 milligrams per liter, which is huge. Now, 2.5 plus, let's say, if it was 1.5 in a bottle, that's 4 in the DO, dissolved oxygen, that's 4 milligrams per liter. So these 4 milligrams per liter will bind 4 times 4, 16 milligrams per liter of free SO2. The wine has been bottled at 36 milligrams of free SO2. So in 2 months, I'm expecting that I'm going to read already 20 milligrams per liter in that bottle. This is a minimum of the problem, just dropping the SO2, even though that's going to shorten the activity, antimicrobial and antioxidant activity of SO2 in the bottle. It is that oxygen that I have in there will react with constituents in wine and will mature wine faster. So this is the reason why we have to be very careful with how we handle the bottling and oxygen during the bottling process.
Can I ask a question real quick?
Yes.
So I know a lot of folks don't have a DO probe. So is measuring SO2, it's a lot easier. Is measuring SO2 post-bottling a good way to estimate their DO pickup?
No, and it's too late. You know, if you're small that you think it's too costly for you to have a DO meter, first of all, DO meter can be used during the whole process of winemaking. So it's really a good thing to do. And there are DO meters with the probes that you can buy them under $2,000. So they're not so crazy expensive, but they're an amazing tool throughout the whole process of winemaking. Because
actually, we just bought one for a winery I work at for about $300 on Amazon. So it may not be perfect, but it's better than not having one at all.
And what technology is it?
I'm not the one who bought it. I just know it was only about $300.
Okay, I would be really careful because, like I said, I would suggest to have a not polarographic, but optical. Maintenance is there's much less maintenance. Not to mention, if you are not almost constantly replacing membranes after few uses or few days or weeks, your readings will be irresponsive and all over the place. So they're going to become meaningless. So you really want to make sure that the probe reacts as it's supposed to. We always tend to be very happy when we have a low readings, but that doesn't mean it's a proper reading. So, you know, when you have 1 meter like that, I would suggest that you go to some other winery who you know they have a decent and well-maintained probes and do the comparison. So I actually brought the demo meter with me because I didn't know what kind of meter they have it here. And they have some meter that I never heard of it. They buy through Cole Palmer, but it's actually a very good meter. It's also optical, and we had our readings within a spec, which was really great. And actually, even the reading of the sparged empty bottle, like going through the orbiter, I can't tell you how amazing it is. You measure the bottle before you go to a sparger. You read the percentages because you're reading in air, not in a liquid. We were getting readings between like 85, 95. So it's about like, it shows you there is 100% of air in the bottle. And as you know, in the air, there is 21% of oxygen. So that's what you have there. Post orbiter, our readings were under 10%. They were like 5 and 6. So that means there is only 5% of 21% of oxygen in there. So that's like, 0.05 times 21, and you're going to get what your percentage of oxygen is in there. It's very low, which means The empty bottle itself mostly has inert gas in there, not oxygen. So that means your DO in the bottled wine will be lower. So on this PowerPoint presentation here, and you probably already read it, it takes a lot of time to prepare wine, depending how large you are and through how many different departments you have to go in marketing and everything. But if you age wine in the barrels, it takes time to go through the whole process of emptying the barrels and blending it, stabilizing it, clarifying it, filtering, whatever needs to be done. And you need to have that in mind when you're planning your schedules. And especially nowadays, it's so hard to get the schedules for the mobile bottlers. I'm hearing sometimes even a year in advance you have to schedule. So you better know what you're going to be doing at what time. And now actually I'm hearing it's even worse because we don't even have a supply of the glass normal. I'm hearing people are already ordering glass for like a mid-June of 2023. So it's really getting difficult. So the abbreviation actually is bottling wine system. This is the system that consists from like bottling tank all the way to filler, and that always needs to be sanitized on daily basis as the bottling is actually is happening. And I'm also talking here about wine packaging supplies incoming inspection. If you're larger, you probably will be doing this. If you're smaller, you will be relying on the vendors to do that for you. And most of the time, most of the vendors are decent and they do this right. But sometimes they've been also all struggling because everybody works with fewer people. So fewer people doing more jobs, mistakes can happen. So it's always important to know that. And you always want to make sure that your supplies shows up before your mobile bottler shows up, or you are actually ready for bottling. You want to have that at least a day in advance or so you can actually see if everything is up to the specs and everything is right. Label is important, looking, on the labels, the alcohol levels, the text that you put, it has been approved. You want to make sure it's done exactly.
Hey, Zoran, we had a question in the chat.
Yes.
Alec is asking, how many people have a DO probe?
Yes, Julie, I think you turn it on.
Yeah.
You can maybe do a quick survey, actually, put it into a survey there and they can answer to you.
Oh, I don't know if I know how to do that on this
Or maybe
Zoom.
Lori knows.
Let me work on it.
Okay. One thing is consolidation is nice for the group of people of small producers. And so if you already, work with someone who already has a bottling line, probably these people would be the best that they have actually a DO meter. But like I said, DO meter can be used throughout the whole process of winemaking. But if not, you can maybe a group of you buy one DO meter and then share it. I mean, it's not impossible to organize that, especially if you're not close, if the distance between wineries is not so big.
Yeah, I think that's an excellent option.
And it's also for other types of equipment, that you might be using occasionally or something. It's a great idea. What actually they did, this was an even larger project in Michigan. Michigan State decided to pay half of the price of the flash detant system, which is kind of important for them because they cannot ripe always, so they want to get rid of pyrazines. And then one of the larger winery decided, okay, we're going to pay the other half, and then we're going to be renting this. And many wineries, they're going there and getting rid of their pyrazines and making wine, and everybody is happy. So yeah, there are different ways of kind of organizing that. So here, when I'm talking about that bottling line system, that includes the final filter and the filler that needs to be sanitized with filtered, softened, dechlorinated water that is over 180 degrees Fahrenheit, steam or hot water for about 30 minutes prior to everyday bottling. Now, when I say 180 minutes, that means I'm sorry, 180 Fahrenheit. That means constantly over 180. You can't have your boiler failing, or maybe using your boiler for washing the tank or something, and the temperature drops under 180. Because if the temperature drops under 180, you have to extend your time schedule that you have. So in an ideal situation, you would have like a thermograph that would measure the time and temperature, and you can have a printout that you know this happens. Nowadays, there are much more modern systems which you can read off your computer, and you can see the whole curve during the process of sanitation to make sure that sanitation has been done properly. For example, yesterday here I was monitoring sanitation, and they are doing it here somewhere at the range 190 to 220 degrees. Boiler is relatively closed. It's self-dedicated to the bottling line, so that's less of a headache, and it's relatively closed. They're using heat exchanger, so the steam is heating water, and then that heated water goes into the filler. And they run it only for 15 minutes, but the temperature is higher. And I said, how often do you guys check? Well, we check at the beginning and at the end. I said, why don't we check every 5 minutes during this 15 minutes? So they check in the middle, and guess what? We found out that in the middle, the temperature was 165. And I said, well, now let's extend, first of all, bring the temperature up to 180, and then do additional 15 minutes. And that's what we did. What happened actually is there was some issue with the centrifugal pump that would circulate this CIP water, and for some reason was, I think, starving. It was start making noise, and wasn't actually pushing the hot water, so it wasn't actually, there was no flow. So that's another thing. You know, one is the temp that you maintain the temperature. On the other hand, you want to know that actually the liquid flows. It can be just cold and 180 without actually water going through. The reason why we like to use hot water, not the chemicals, is that hot water heats all the metal. So even if something is outside, not just inside the system, it'll kill. And that's the whole point. We also want to use chemical sanitation, at least like once a week, if everyday bottling line is used. And the reason for this is there is a caking, there is biofilm formation potential, and you want to make sure that we peel off anything possible, any stains that might be in stainless steel. In order to check that, you have like a side glass on the filler bowl. You can take a strong light and poke inside and see actually if you see the clear stainless, or you actually see some colored or discoloration in there. Also, the bottle rinser actually is sparger. Most of the wineries in the United States are not using liquid to rinse the bottles, unless maybe for the sparkling wine production. But many rinsers or spargers are made to use gas or liquid. So that's why it's kind of called rinser. But because they're coming in contact with the bottle, it's important that those are getting cleaned. And we clean them, we can spray them with 70% of ethanol. And if we do have a bioluminescence unit that we can measure the microbial activity, ATP of the microbes, we can use that to see actually how clean our bottle rinsers or corkers are. Corker jaws need to be cleaned and wiped with 70% of ethanol and lubricated. The excess lubricant needs to be wiped out. And also after you lubricate, you should be pushing a couple of corks through the corker jaws and see if they're leaving any streaks from the metal shavings. And if that's the case, you discard those corks and you wipe again before you actually start using corker. And as I mentioned here, ATP swabbing is used to confirm sanitary conditions of the rinser, filler, and corker. Also, if you're using excess grease on the corker where there's a shoe that creates the vacuum, that grease can fly over everywhere. It can end up actually in your bottle, and it can end up all over the place. So you want to make sure there is no excess grease or oil anywhere on the equipment. We create also a lot of different paperwork when we get bigger. So I don't know that would be this really totally related to you, but it's nice to have the paperwork so you know what you were actually bottling, what materials you were using. So next time you use the materials, you know, you can find it actually in your records. Wine specifications are really important, and I do have actually this one here. I just put here various wineries, which they were actually representing different constellation wineries with different targets based on the types of wine and also winemakers' desire where they want to have something. And as you can see here for the O2 in the sparge bottle, 0.6, that was 0.6 actually. That was before, that's when we were using polarographic and we were reading actually milligrams per liter, which is completely incorrect. So I don't even know where I would put this number now. As I was telling you earlier, that today with the optical diometer, we were reading under 10% of oxygen left in the bottle post-sparging. That would be 2.1 percent of oxygen. That would be really good result. Dissolved oxygen in wine, 0.6 target. The second winery has less than 1 or less than 2. The winery number 3 want average of 0.8, definitely under 1. Many wineries wouldn't start bottling if they cannot get oxygen in the starting bottles after the first rounds under 1. They just wouldn't. And the reason is we historically learned that if the DO doesn't go down, quite often actually goes up and doesn't go down. And if that's the case, everything that you produce out of the spec. And you want to have always minimalist number of bottles produced out of spec. What I would do with the wine that is maybe outside my spec, if there is a way, I would mark those cases separately and use them for the bottling. I would use them actually for the tasting room rather than just regular population that would go all across the country, because this way we have a full control over those bottles if they go bad or not. Most of the time they don't, just there's a slight difference in maturation, but you want to have all the bottles uniform when you are bottling wine. And as you can see, the winery number 5 has target under 2.5 milligrams per liter of oxygen. That's because the equipment at that winery is old. Actually, they bought some of the fillers from the Heinz ketchup, which is unbelievable. It was like in 60s. But what I really admire, the team of mechanics that they work at that winery, they're capable of maintaining still, like almost 60 years later, they're still producing wines in those with those fillers, which is just unbelievable. Free SO2, these are different targets. And again, sometimes when you cannot drop the DO significantly down, like this winery that has actually target over 2.5 or average 2 milligrams per liter, you can see that their free SO2 targets are much higher. Normally, from winemaking point of view, free SO2 is based on the pH of wine, and also maybe how long that wine is going to age before they will be released. Also, what kind of closure is used and all kinds of different things. But again, if you know that you cannot reach your targets of to get a minimal DO, you might actually bump up that SO2 for that reason. Also, in production of, for example, products like Moscato d'Asti, which is a semi-fermented wine that might have a alcohol anywhere from 5, 6, 7% to 10%, and lots of sugar, 80 to 120 grams per liter. In Italy, when they bottle these wines, their target free SO2 might be 60 and 75. And especially because some of the Moscato d'Astis, you know, that used to be just consumed as a local wine, but nowadays Moscato d'Asti is popular and it's drank all over the world. So you have to have a higher SO2 in order to try to protect that wine. Total SO2 Many people are not even monitoring, but there are legal limits for total SO2. So you need to know what are the legal limits and to see where your actually range is. Once when you monitor total SO2 during the winemaking and you do notice that the numbers are high and sometimes you have a hard time reaching your free SO2, your wine is already went through multiple saturations and they are getting actually less life on the long term. So seeing actually that your total SO2 is not actually high and the free you adjust easily, you know that your wine is still very vibrant and young. CO2 in wine, I found out many wineries don't even analyze it. I would definitely suggest that you know what your CO2 in the wine is, because that changes completely the flavor of wine. And definitely sometimes that's really important to keep the crispiness in the wine. So quite often we want to have a CO2 over the threshold in the wines type Pinot Grigio, Sauvignon Blanc, Moscato. At the same time, California Chardonnay that is made in barrels, you don't want to have CO2 over the threshold, so you probably want to be under 800 milligrams, which is about threshold that you will be able to taste any kind of spritz or bite. And that's why this range is actually, range here depends what kind of products they're making. That's why I have various levels here. In red wines, most of the time we don't want to have a really apparent CO2 unless we make some frizzante, or you have some Beaujolais style wines. Or maybe if you're kegging wine, but that would be a different story for those by the glass that might actually can benefit from some CO2 in there. Temperature of wine is really important when you are bottling for multiple reasons. One is, if it's a higher differential, you're going to have a problem with reaching the volume, what volume of wine you want to have, because all the drawings are rated on 20 degrees Celsius, 68 Fahrenheit. So you need to have a tables that tells you about the coefficient of expansion to know what your now new fill point is if your temperature is much lower. During winter time, there are multiple temperatures that are really important for you. It's the bottling tank wine temperature, bottling room temperature, glass temperature, and that would be pretty much it. If there is a big difference there, you might have a condensation, dew point, and that will create huge issues with the label application. Vacuum only is for the stoppers in order to put the stopper into the bottle. If we don't use vacuum, we would create pressure. Pressure is not good because we will compress all that air that is in headspace into the bottle. So we will actually get more oxygen in the bottle than that just regular without pressure. With vacuum, cork goes easier into the bottle, and that vacuum doesn't need to be very, very low. So it's not actually PSI is for the pressure, so that's over 0. The vacuum is measured in inches of mercury or millimeters of mercury. So this -5 is millimeters of mercury, not -5 PSIs. It's a different gauge. So if you ever look at the gauge that goes into the vacuum and goes into the pressure, it will have actually even the lines that are in there, they would be different. So -5 to 0, it's actually that those were the targets for the winery. But if you're talking to cork companies and bottling, they can go slightly into slight plus, maybe like up to +2. I also learned that if you are corking large bottles, 1.5, 3 liter, 5 liter, that those numbers can be much higher. They can go even to +5, +7 and not creating any problems. And the last one is a wine sparging with nitrogen. That is during the process, depends how the bottling runs. There could be multiple applications where actually wine is sparged with nitrogen, or actually even evacuation, additional evacuation of air with the sparging empty bottle just before gets filled at the filler. Any questions or comments, Julie?
Not yet. This is good to see that there's some variation from winery to winery, or winemaker to winemaker. That's definitely true from what I've seen as well.
And this is what also shows you when you're working with mobile bottler, it is critical that you spell out what you want and that you know that they're actually capable of delivering it.
Yeah.
So, because I'm talking about mobile bottler, I'm just going to show you this slide. And actually, I don't see everything because I have to move the video. So, because when I was with Constellation, we worked at many different facilities with mobile bottlers because depending about the volumes, sometimes it doesn't make sense to use large bottling line for bottling something small because it just the scale is not right. And because of that, you lose a lot of valuable, the most expensive wines, the smallest volume, you can lose a lot and you can also ruin the quality of that wine. So it makes more sense than to bring mobile bottler. And we found out different mobile bottlers, they might have different approach to how they're doing things. And we want to make sure that we first provide what they need, which actually I didn't put much of that here. That's something that our bottling manager was managing. This was more from the quality point of view. We put here about what we talk about wine, different specifications, frequency of checking, and so on. So for the wine alcohol percentage, we would accept that, we don't want to have alcohol difference more than 0.1% of alcohol by volume. And when we check that, it's at the startup. That's the important part. Later on, we don't expect to alcohol vary once when the water residue has been flushed.
Zoran, maybe you'd, because we talked about it before, if you are on your startup and you have finished rinsing your filler and then you bring in the wine and you then usually what do they do? The 21st 24 bottles, they will.
Oh, yes. Yes, that depends how many. Yeah, so what happens actually, after you finish hot water sanitation, your system from the bottling tank to the filler has some residual water that needs to be somehow pushed out. Different places do different things. Some people just rinse with water and then mix with wine. And then if they make cheap wine, they even drain the wine out, just like people would do in the beer industry, and they would start bottling. But quite often we make a pretty expensive wine that we would be just dumping wine into the drain. So we actually developed a system of nitrogen pushing gas with gassing actually the line and pushing the wine water residues through the system. Ideally would be that you can drain that water in multiple places. So let's say one of the places would be push it from the bottling tank to the filter, the final filtration, and drain it there. And then pushing from there to the filler and drain it there. Different filters, they have different ways how you can actually, sometimes you might not be able to drain 100% of stuff because it will be stuck and probably you would have to bleed the valves, or you have to bleed it by bottled actually into the bottles and then dumping the bottles.
So we talked about how important it is to check your alcohol after you decant those 24 bottles or whatever quantity.
Yes, that's what I'm going there. Okay. Alcohol checking, if you don't have an alkalizer, you're out of luck. You can use a bouilliometer, but it's going to take you a long time to actually get the numbers. And how good numbers will be, that's the question. So if you have alkalizer, it's easy, but even with having an alkalizer, it takes time to get the numbers. So what I suggested actually, and I implemented that and it works great, you take your Brix reader refractometer, the one that you drop the juice and read sugars. You can take a drop of wine from the bottling tank and you use that number as a reference. So let's say your reading is 7.5 there. Then you take the drop at the filter, if you can actually drain it at the filter, and measure the number there. So if the number there is like, I don't know, 5.6, and you had 7.5, you still have water, you push it more with nitrogen, drain that water out. And once when you get number within the 0.1, so if it's 7.5, as soon as you get 7.4, you can start pushing now the remainder of the line all the way to the filler, and repeat the same thing in the filler. If the number is 7.4 or 7.5, you are good to go. You can start filling the bottles. Filling the filler bowl first up to like a half or 1/3, and then start filling bottles. If it's lower, again, you have to push more. This way, you will probably get rid of more water from the system, and you probably would have to drain less of these bottles that you're going to fill. Quite often, you have to do 2 rounds. But if this is successful, maybe you can do less than 2 rounds. Because now what you're going to do with this wine, some people might, that they have larger production, they might take that wine and put it in a large tank that hasn't been bottle ready yet. And that way you can recover and save that wine. What you're going to do with the bottles? Well, you don't have a rinser to rinse the bottles. And if you look at from microbial point of view, you might don't want to reuse these bottles. Or actually, if you really are diligent, you can maybe wash them nicely with the hot water or something, and then put them back into the system and fill them. But overall, like if you do daily bottling and daily you dump 2 rounds, of your wine and rounds of bottles, that's a lot of money too. So you have to find a practical balance in between that to reach your goals. So after you reach the alcohol level and you know alcohol is good, your next step is going to be to see what the DO is. And once when your alcohol reach your target, your oxygen, dissolved oxygen reach your target, now you can start with the bottling. One important thing with bottling is that any stop and go on bottling, that's not how the bottling is supposed to work. Bottling is supposed to run all the time. When it runs all the time, then it's going to produce the best wine and it's going to work the best. Your numbers and figures, everything will be within a spec. Okay, so I don't have to maybe describe all of this stuff here, but if
I was
there's
just gonna say one thing to that, Zoran.
yes,
If there's a mechanical problem on the bottling line and you go for more than 30 minutes, that's when I'm willing to wait 30 to 45 minutes if they're working on something. But if it gets to be delayed beyond that, I'm going to ask them to send the wine back to the bottling tank. You're just picking up too much oxygen in your filler. It's just not good for the wine. So we didn't really talk about that, but I always ask for the wine to be sent back if they feel like the mechanical problems are going to take them more time. Just send the wine back to the tank.
very good point. It's not something that we always know. That's the major problem. And always our focus is how to fix the problem and how to find somebody who actually knows something about it, or how to find somebody who might have a pieces that we are missing and so on. But somebody always has to have that in mind. Okay, we are approaching this time, so yes, take it back. Now, that really depends. Taking back, if you know that that's what happens and that's how your filler behaves, that your DO will be going up, yes, you have to take it back. But some of the newer modern technology now, fillers, they work differently. That vacuum that gets sucked from the bottle to either before the bottle gets filled, and maybe you inert the gas in empty bottle before you actually start filling, or the vacuum that actually adjusts the fill height post-filling the bottle to the level where it's supposed to be. Those vacuums in an older style bottling were going inside the filler bowl. And if you are idling, you would have some filler spout, maybe one or more, that might be in that intermediate state and wouldn't be sealed, which means would be sucking vacuum constantly into the filler bowl. Now, there is a baffling plate there that's supposed to kind of keep the separation between level of wine and a headspace. And so then there is constant nitrogen that actually is going in there that's supposed to kind of mitigate that issue. Definitely DO will go up. And not just that, if you are even constantly sparging with nitrogen, this now dead volume of wine there that is not moving, if this wine is delicate and has good flavor and has a CO2 level significant, you're going to be blowing off that CO2 during the same time. So the wine is going to taste much more flat and less crispy. So for all these reasons, would be important to take the wine back if it's possible. Not all of the bottling line, they have a line that you can take it back. Quite often you just have to empty it by actually filling the bottles or just draining it down, which you create now a microbiological nightmare because you do this. So if the problem persists and fixing is not done within the half an hour, 1 hour, you might have another standard where you're going to say, if my line is idling for more than 2 hours, I will have to abort bottling and I will have to do resanitation again before I start again. Now, the call for that, again, it's based on experience and you see how you can mitigate sanitary conditions. You might end up spraying the filler spouts every 15 minutes or every half an hour and before you restart, and that way maintain the integrity, free of microbes. Also, if you're running dry wines, is less of an issue, but if you're running sweet wines, definitely this is the case. 2 to 3 hours, you have to restart sanitation, which is going to take you another, depending different wineries, it might take you anywhere from 1.5 hours to 2.5, 3 hours. So you need to have that in mind, and whether the restarting actually that day makes any sense is the question. But if this is your mobile bottler and you have no options to get them for another day, you brace yourself for a long day of bottling. All right. How are we with the time? We're almost to an
It's
hour.
5 o'clock. We have another half hour.
Oh, so it's for 1.5 hours.
Yeah.
Okay. All right. So here I also have some demand from the mobile bottler, and that really depends what package I'm using, different level, the heights of the bottle or heights of the label on the bottle, and also registrations, and what are the tolerances or tilt of the label. All of that stuff we can actually put here. And then label coding. Label coding, huh?
I was just gonna say, really important to have a conversation with whoever is doing the bottling for you, because that plus or minus tolerance is really different depending on who you're working with. So if you personally are at a 1 millimeter tolerance and the bottling line is on a 5 millimeter tolerance, you're gonna have a very challenging day. So it's really important to have that conversation ahead of time, what you want your tolerance to be, and everybody agrees to it. It just makes your day a lot easier working with those people.
5 millimeters, that's a gross.
I know, but I've seen it.
I agree with you. And this is something that you can find between a large production facility versus smaller. And that's how you're going to make your call to see, is this something that is acceptable to me? Within the Constellation, we had a large bottling facility. They could never stop the line. And I have a luxury to stop the bottling at Clos de Bois and Mondavi for the purpose of any kind of adjustments. Actually, lab technician, no, a quality control technician could do that call. But it has to be a trained person. They know what's the reason. It's not a ridiculous reason. So in a fine wine division, we had, let's say, 1 standard deviations tolerances, while in a large production where they cannot afford themselves to stop bottling, their tolerances are 2 standard deviations. And yes, if that's not acceptable to you, then you have to really seek for someone else. All right. What else are we missing from our list there, Julie? Oh yeah, this was another sheet just to show you example what kind of preparations our QC people were doing prior to bottling. They had actually a little Photoshop area where they would take images of bottle front and side just to see how the registration heights are different and where they can be. Some people like to line up the back label with the bottom of the label, with the top of the label, and some they love just in the middle. So you have to satisfy everybody who wants it. Here on the right side, we had all the packaging that we need to have with different codes and the number, sizes or whatever was there. Also what it's supposed to say on the label, and even type of paper that is used, and also important text. You want to make sure that whatever your wine is done, what is legally accepted at TTB, that needs to be typed there. If this is wrong, you're going to be in trouble. You can't use that label if this is not right. And then also,
I guess one of the things that, depending on who you're working with, I've definitely worked on mobile bottling where they had me sign off on all we got to the point where everything was dialed in and all the equipment was exactly where it wanted to be. And then they made me sign something saying that I approved all of it. So, including that the alcohol is correct and that all the percentages that match with the cola, that sort of thing. So each winery is different. And there were some that were, they didn't want any of it on them. They wanted you to sign off that everything that you sign off and say everything is as I said, and that if there's any legal issues, it's on me and not on the winery that did the bottling. So I don't know if you had to deal with that.
Well, I would say that definitely winemaker is responsible for cola alcohol. Go ahead. Okay. Winemaker is responsible for cola alcohol that will be sent to the printer, to the labeling company. And then after that, when the labels are received, somebody, that can be a winemaker or anybody else, based on those winemakers' note and approval, they need to proofread everything that is on the label. And let me tell you, proofread, because I learned in another winery post Constellation, everybody was looking and everybody was signing, but they weren't actually reading because it was a wrong alcohol level and everybody failed. So you are not just make it like you are really screening it. You have to really use brain and mentally record that, yes, this is correct, or no, this is not correct. It's not just a busy work that is just needs to be done. It needs to be checked. Because if you produce it, if you find it afterwards, then you need to ask for forgiveness and get additional approval. Or even worse, you have to buy other labels, remove these labels, or label it over, which is never fun.
So you asked me what else we were going to talk about. We talked about filtration. So we talked about final rough filtration, additions to wine prior to that rough filtration, as well as the membrane filter. I don't know if you wanted to talk about that.
Yes. Okay, so filtration is important, and the closer to bottling, you do a final filtration prior to final filters. Normally that is done as you are actually going from bottling tank to the bottle. The closer is done to the day of bottling, the better it is. There is so much of wine stuff that can get reconstituted post filtration that will create problem to run through the final filters. The point of final filters is really to screen just accidental stuff. So the pre-filter of the final filter is actually depth filter that's supposed to remove solid stuff, hopefully just the crystals. If it's an amorphous material, it's going to get clogged much faster. The final filter, or filter that is actually absolute to 0.65 or 0.45 micrometers is actually a microbiological reducer. I don't like to call it sterile because it's not necessarily always sterile. There are ways of making it not sterile, and it's scary, but that's why I call it a microbial reduction. So for example, on the Parker filters, pre-filter is removing stuff like amorphous stuff or crystals. It also removes about 10 to the third, 10 to the fourth of microbes. And then the final one removes 10 to the 7 microbes. I'm telling you, you should never want to have 10 to the 11 microbes in your bottling tank to get the one into the bottle. And normally, if you do good sanitary conditions, do good cleaning, and you don't have a biofilms through your pipeline system, your bottling tank, and also you are using even cross flow or PET filtration or lenticular filtration prior to bottling, your bottling tank should have less than 10 colony forming units. But even if it's just less under 100, you should be good to go with filtration and you shouldn't have a problem. Well, in the modern times now, a lot of winemaking is done by our vendors who makes all these different fine products that they make. They say your wine is going to taste delicious if you are adding this gum arabic, or you're adding a CMC, so you save energy on cold stability and blah, blah, blah. All these late addition to the wine can also shift equilibrium or actually change the filterability, and they might actually clog your filters. So you need to know what you're doing and how the stuff needs to be done, so you don't find yourself surprised there. Anything else about filtration, Julie?
Well, we talked about the timing based on varietal. Some you can get away with filtering a week in advance, and some you need to do, a day or two before.
Yes.
So maybe you can talk about colloidal stability.
Yeah, if it's a minimal intervention is done. So yeah, you crush your grapes, you ferment, and you make your wine, without all these additives, probably you shouldn't have a problem, unless it's maybe Pinot Noir, which is kind of known for difficulties during filtration. Now, you would be surprised, but water can be your big problem that creates issues with the colloidal issues with the filters. Some of the stuff are probably colloidal that comes from the grapes of Pinot Noir, but also if your water is rich in silica, and especially if you have a higher level of colloidal silica. What colloidal silica does, when it shifts from water pH, which is pH 7, to the wine pH between 3 and 4, it swells, and literally swells in your filter and just clogs the filter. Once we were bottling Pinot Noir in Central Valley, and we clogged the filters. It was actually bag-in-a-box filtration, packaging. And I was so curious. I told the guy from R&D down there and say, why don't you send us that filter for analysis? And let's see what is going on. It was a final double pleated filter. It was like, I think, it was Sartorius, I think. It was 0.65 and 0.45 final, double plated, like accordion shape in the filter. And the measurements came back. The outer layer of that double plated material had about 1,700 milligrams per liter of silica. And the internal one was 700 or 800, which means that a lot of silica clogged this final filter, but also some silica passed through. And then that silica can create instabilities in your wine when it's on the market. So you really want to know what the water quality is. One thing is, like you might say, well, I filtered my water. Well, that's fine, but water also has dissolved minerals and silica which they can drop out of the solution and actually create the problems. So sometimes we like to know what that water level is, and maybe we need to use RO or ion exchange to get rid of minerals, excess minerals and excess silica before we use on final filtration. When you talk to filtration companies, they will tell you how much silica. No, actually, they're not normally freely, voluntarily will tell you how much silica or minerals you can have before you can do filtration, because they don't care if you clog your filters faster. You're just going to end up buying more filters. But if you tell them for specific applications and you insist, then they will tell you all these tight filtrations, they should be 0 colloidal silica in the water. And quite often they just say less than 1 milligram per liter of silica. And I will tell you, the valley, well, it doesn't even have to be a Central Valley. It can be also Napa or all these areas. If you're using well water, your silica, and actually not to mention in Livermore Valley, the hardness of the well water there was like through the roof. I've seen numbers 250 to 330. And I don't think so we had the silica numbers, but the other silica numbers that I've been seeing, they range anywhere from 25 to 75, which is really high.
So,
And,
Rhonda had a question. Do you have opinion about cross flow versus lenticular filtration for red wine?
Okay. Cross flow is a great technology, and there are also different types of materials. So it depends what you're filtering, whether it's heavier stuff, lighter stuff, you know, you're going to use different materials. It's great because it pays out quickly, considering how much more wine you're going to save by actually running cross flow. But on the other hand, depending what type of wine is and what your belief is into filtrations, you might think that that might, disrupt your wine. If it's properly done, not necessarily, but I did personally, in my experience, using like 5-6 different types of cross flows and using a couple of different materials for the cross flow. In any sense, in the blind tasting, in the preferences that we were doing, whoever was able to guess the reference, we took their preferences in consideration. We found out that the cross flow was only impacting thickness, volume of wine, not the flavors. And if that volume and creaminess is the key for your wine, then you probably don't want to use cross flow. You probably want to use lenticular filters. Lenticular filters are pad filters closed in space, so they're not in contact with air, which is nice, and you don't have fruit flies flying all over the place. They're nice. I tested some of the lenticular filters, 5,500, I think, sites. They're also good in microbial reduction significantly. We were able to reduce 10 to the third, 10 to the fourth, but you have to. There are different tightness of the lenticulars, and I think those were like EK filters for the lenticular that we were using.
Now, I would say we did a trial when I was at Sterling where we tried, I think, 6 different companies' cross flows and compared it to DE filtration, and there was a significant difference as far as flavor profile. The DE and the pad filters give a flavor that the cross flow does not. So I like the flavor coming out of a cross flow in general compared to other types of filtration.
So you were getting undesirable flavor added
from the filter media.
Yes, that is possible, but that can be eliminated if you do a good preparation.
Right.
And not always. Yes, some materials. I remember we were using some Filtrox materials, no Filtrox, Herbsle materials from Germany for the filtration of the lees, like with a kind of Kisselgurt type of filters, and that flavor was always there. No matter how we rinse it with citric and water, hot water, and all kinds of stuff, we could never get rid of it. Mm-hmm. DE, normally, if it's pure DE and it's not contaminated with TCA, which can happen, depends where you store it, And if you use the citric rinse and recirculate, and also the initial wine recirculate before you actually let it filter through, most of the flavor goes away. But yes, who knows who is supplier? This is another, well, that's another story. But anything that you buy that you're going to be putting into your wine, I suggest you to take a little small amount, mix with the wine or water, distilled water, put in a glass and smell it and see if it has some off character. Also, with all your enological materials that you might have from previous year, before you use in the following year, make sure you smell it. Especially like nutrients, if there are open boxes that smell like a chicken feed, please dump it. Don't use it.
That's a good suggestion.
Yeah.
Well, we have about 15 minutes, so I just want to open up the conversation. If anybody has any questions for Zoran, we're happy to answer any questions that people have. And if nobody does, then maybe we can talk a little bit. We talked about nitrogen gas and CO2. Maybe you can bring.
Oh, yes,
something
yes,
about
yes, yes. So when you are, actually, that's a thing that I want to ask you, Julie. Have you
Okay.
ever seen people adjusting DO in a tank by actually looping through the pump and inerting the gas inside the pipeline that you are actually recirculating through the tank?
Lately, I'm seeing people using dry ice and actually dumping buckets of dry ice into a tank and measuring DO before and after that.
With
Some
no
people-
mixing, just dumping it on the top.
Yeah, so you get a pretty good mix with that dry ice for sure. Or they're using nitrogen gas and sparging the tank. But your question about using doing something in line, I have not seen that.
Okay, I would say personally, I think the inline sparging is the best sparging because you are not flushing flavor out.
Mhm,
No,
okay.
if you're sparging your tank and after a couple of hours you still didn't reach your DO target, something is wrong, and your whole cellar smells wine, beautiful wine. Everything that you smell in the cellar is not going to be what your consumer is going to smell in the bottle. That's lost. So bear that in mind. So if you are moving wine, like a bulk shipment, you know, all that stuff, make sure that first of all, that dry ice that you are talking about,
Mhm,
I would put the dry ice on the bottom of the tanker, as am I
mhm.
filling the wine. And then depending what your DO is in a tank, you know, maybe you want to even inline sparge as you are putting into the tank. And then halfway through, you want to drop additional dry ice on the top of the wine as you are filling it in all the way through. Also, if you're shipping tankers, you want to make sure that you load them fully. Then when you're ordering tankers, you need to know the volumes. You never underfill the tanker, because if you underfill the tanker and you have your bottle, you can imagine you're going to be shaking all that headspace air with the wine, and as you receive it somewhere else, hundreds of miles away or whatever, your DO is going to be through the roof. It's
So if you don't know about your particular trucking company, there are some that are known to be using trucks that were intended for other liquids and not for wine. Cherokee comes to mind. They always send trucks that are too big for the volume of wine. So you're limited by the weight of the truck, and all of a sudden you have a headspace of maybe a couple 100 gallons. But you really have to make sure you talk to your trucking company and find out if they are able to fill full tankers, or ask for 2 or 3 compartment vessels rather than a full 1 compartment truck. That's really important. And make sure the people that are shipping and the people that are receiving are measuring the dissolved oxygen in your wines. I've seen a lot of wineries where they're not checking that. So, and then there were a couple of questions here on the side. We adjusted DO through pumps at the wine group. So Julian is saying he agrees using it through the pump is works really well. And when you add dry ice to a wine, are you increasing your dissolved CO2? And yes, you are.
This is
So-
something that I want to ask you, Julie. So
Uh-huh.
there is you can calculate, you need to weight, you know, what you're adding, the amount of dried ice, and
Mhm.
then also volume of your wine. And based on this, you know, and then also what the temperature of the wine is. Normally, the maximum solubility is at 4 degrees Celsius, but then everything over is less.
So I'm also a proponent of having a certain amount of CO2 in every wine I bottle. So that's one way I'm actually measuring. For instance, if I'm doing a red wine, I'm probably around 800 to 900 parts per million of CO2.
Really, even in red,
Yeah.
that's
And
kind of like a threshold just there.
yes. But
Okay.
it allows the wine to have a freshness, but it also increases the ageability of the wine. So I like having some, especially if I know the wine's going to sit on the shelf for a fair number of months, I like having the higher CO2 for the reds, but I understand a lot of people are probably closer to 300. For
Yeah.
the whites, I'm probably closer to 1,000. And if I'm doing a sweet white, I might be up at 1,500. It just depends on the wine and what I'm trying to do, but it's nice if you have the opportunity to taste the wine before you add the CO2 and after, and then you can start to see what it adds and enhances the wine.
Well, CO2 in the wine is actually additional acid. It's carboxylic acid.
Yes, it is. Mhm.
Also, it has a tactile sensation and also enhances the fruit character and freshness, crispiness. So if that's the style, that's what it is.
Mhm.
That's what the CO2 will do. Now, what we haven't talked, but we did talk before this meeting, is about if we are over sparging with nitrogen. And the reason for this could be because it's very inefficient, static in the tank,
Mhm.
or because your diometer really is not responsive. Some of these polarographic diometers, especially in the cooler temperatures, they are irresponsive, and their resolutions and the limits are really not good, especially in that range where maybe your target dissolved oxygen in the bottle tank is like below 0.5, you might never reach it. In reality, you might be already 0.1, but your polarographic meter is not going to detect that.
Mhm.
So that's really important. And so if you are over sparging with nitrogen, and nitrogen is the gas that has the highest affinity to be dissolved, which means it's going to push all other gases out, you might lose some SO2, you might lose some CO2, and nitrogen itself will change the flavor, the way how the wine tastes. So you have to have that in mind.
Oh, I definitely tasted a wine the other day that had too much nitrogen in it. It's a very strange flavor profile to have all that nitrogen in there.
So tell them, what did you taste more with the more nitrogen?
It has almost like a creamy texture to it. So if you've ever had a Guinness and you know the texture you get from drinking that beer, it had a similar kind of creamy quality, and CO2 never has that. So I was like, what did they do to this wine? So this was something I tasted as a bulk sample that somebody was trying to sell. So I think they over added the nitrogen, but it was really readily apparent that it wasn't quite right.
Yeah. Any
Okay.
questions?
Anybody have any more questions? I did see here a mention from Julian that you have 4 optical DO probes, 2 for tanks and 2 for bottling, one in the lab and one on the bottling line. So there's some people here that do have the optical DO probes that you're discussing.
Now, one thing that I want to ask you, Julian, is ideally would be that you use the same type of probe also. But I know some design of the probes are not designed well to actually fit nicely into the bottle. You always want to have a probes that actually go nicely in the body of the bottle. Can you tell us, are those all the same ones?
Yes, they are the same make, and so we can use our bowel probes in the tanks as well, but they don't float. So you have to pull a sample from the tank well and sparge it really well to have the same results. And we have tank probes that designed for submersion and built really solid, so they don't break, in the cellar. And so that's why I have two different systems. But I can use my bowel probes in a tank as well if I have to. There's ways of using that, but they have the same exact technology, the same Hawk, make, and you can even interchange the actual light emitting and absorbing surface between the probes.
So the numbers are comparable. The reason why I'm asking why it's
close.
important to have similar or same, so the number of your DO and pickup into the bottle is actually relatable.
Yes, we did actually a comparison with Wood Family with two Hawk probes and meters, like side by side, and they were within like a few hundreds of a ppm or milligram per liter, like so the technology and the make between each other, they're very, very comparable.
Okay. Now, are you measuring total package oxygen?
What I do is I watch the when the oxygen finally absorbed in the package, I just check the sulfites, and that's kind of a feedback on the total package oxygen after a certain time, when I assume that the oxygen level has went down really low. So we check the bottling oxygen, but your inversion technique, several times. I don't know. We don't do that. We just watch the immediate pick up, and then I follow downstream. Where the sulfites been or when.
I understand, but it's after the fact, and there is nothing you can do about it. The thing is, by checking it at the time of bottling, first of all, checking various spouts just for dissolved oxygen tells you that you have uniformity of your spouts. If the proper preventative maintenance has been done, all the gaskets, all the seals, everything has been changed, and so everything operates the same. And once when you read higher DO, there are certain aspects that you are looking where your high DO can come. When you are doing total package oxygen during the production, you can see whether that pickup is something that you think it's normal, or it's actually completely abnormal in high. And if it is, where this is happening. Is there a failure with my corker? Or if it's a screw capping, is it a failure in the amount of liquid nitrogen that I'm dropping, or my speed and the weight is not good enough? And these are the kind of parameters that you're looking at that point, more than just like what you do from your single bottle that you do a couple of months later. Yes, that tells you after the fact, but here you can pinpoint and actually make sure that you uniformly produce your product. And by measuring only dissolved oxygen, we are just getting the partial information.
Yeah, that's correct. I see you very heading with it. We do several checks, and it was good to hear that you suggesting of checking throughout time, and so actually seeing how it changes. And we did notice a variation throughout the bottling process of oxygen levels.
Oh, quite often that's the case. Yeah, that's why it's so important to find, and this is a great tool to do it.
Yep.
So does anybody else have any questions? We have about 3 minutes left. So if anybody has anything they want to bring up, we're happy to hear a question or a comment. Did you want to summarize anything, Zoran, before we head out for the evening?
There's so much stuff, so many of these little different things. I'm glad that you actually are kind of checking stuff that we don't forget something specific. There's much more we can talk about it, but I think for this time and this meeting, I think this is good enough if there is no more questions.
Great. Well, thank you, Zoran, and thanks everyone for joining our conversation. This has been recorded, and for those that weren't able to attend or only saw part of it, we will send a link out so you can watch it at a later time. So thank you again, Zoran, and we'll see you soon.
Thank you very, very much, everybody, for listening. And yes, if you have any questions, please shoot them to Julie.
I'm happy to forward on to Zoran as well. Thanks, everybody.
Thanks.